Okay, so we're moving on to question 2. Exciting. This question is fairly very difficult. So no worries if this went over your head or you guys didn't know where to start. And when I walk through this question, instead of just giving you guys a solution, I'm going to give you guys a series of logical steps that you guys can take to get to the solution yourselves. This problem doesn't need to be solved with just guessing, although it could, but there is a lot of logic here behind it. Exciting. So we're given some min heap where we have each letter representing a unique number, okay? And some students were confused. They thought that the letters or the letters corresponded to some ordering, but all we know about these elements is that B must be greater than A if B is less than A in the min heap. We have no idea about the relationship between B and C, okay? So we have this starting array, which looks like this heap over here, and then we perform 4 operations, and the array changes to this, which looks like what I drew below. Okay, so let's try to figure out, okay, I had the answer for the next part. Let's try to figure out what these possible operations were. We know the first one is a remove min, okay? So I'm going to put down my observations here. So my first observation is if the first operation is remove min, it means that A was removed. Okay? My next observation is that we see here that C like disappeared. So the next observation is that C was removed. Nice. Okay. Let's keep looking. Let's do some more observations. The next one is that we have this X here, so we must have inserted X. Inserted X. Okay, the last thing that we can conclude, this one's a bit trickier, is that if A was removed and A exists in the final configuration, that means A was reinserted. So we inserted A. Okay, so here are our 4 operations, but we don't know the ordering of these 4 operations quite yet. To figure out the ordering, let's take some more logical steps. Okay, the first logical step is we know that, let's look at the relative ordering of C being removed, okay? And let's also look at the ordering of inserting A, okay? And we know at the top that A was removed, okay? So looking at the potential orderings, I'm going to make the claim that we must have inserted A after, okay, after C was removed. The reason for this is looking at this heap, the only way for us to remove C is after the removal of A, C fills the void, okay? I'll show you guys what that looks like. Let me change the selection mode. Okay, so my claim is that the insertion of A must happen after the removal of C. Okay, the reason for this is the only way for us to remove C from this min heap is that after A is removed, after A is removed, what will happen is G will get promoted to the top, and then we have a choice. Should B or C fill that void? Okay, the only way for C to be removed is if C and G swap, right? So that's like one conclusion that I've come across. And why that's important is that C is now at the top, which primes it to be removed at a later point, right? And we need C to be removed, okay? What's also important is that since C is at the top, we know that C being removed must come before the insertion of A. The reason for this is if A is inserted, let's say we insert A at the bottom, we know that A is less than C because A was less than C in the original min heap. So if we tried inserting A before we removed C, what would happen is that A would go to the top. And the next time we call remove min, A would be removed and not C. Okay? So with that in mind, what we know is that we have a remove min at the top, then we have a remove min, right? And then we have an insert A. Okay? The last thing that we need to do, we know that these 3 relative to each other are in this ordering. So all we need to do is figure out where the insert x should go, right? So there's 3 places the insert x can go. It can go in between these two, or after, right? That's the only thing we need to do to figure out. So the insert x is, I think, the toughest part of this problem, and it comes from the fact that x, let's quickly look at it, x is like over here in the heap, right? How in the world did x get there, right? So this is like pretty tricky, and this took me like a bit of time to figure out too. So this is kind of cool. In order for x to get here, the only way it could have possibly gotten here is that we initially inserted x at like the bottom rightmost spot. Then what we did is we probably removed the root, x got promoted to the top, and then x bubbled down to this spot. Okay? Let's make that a bit more official. So given this starting configuration, we have, okay, I changed it up a bit. Yeah, so given this starting configuration, we know the first thing that happens is that A is removed, right? What happens after this, what we've concluded, is that C fills that void, because otherwise C is never going to get removed in the future. After C fills this void, this is like maybe a bit of a jump, but I'm going to conclude for a fact that we must have inserted X before we removed C. The reason for this is that we need to insert X before removing C so that after removing C, X gets promoted to the top, and then X, right, using sinking or bubbling down, will bubble down to this spot, right? And B and E, oh no. Yeah, and then B and E will get swapped, right? So just reiterating, we want to insert X before removing C so that X gets promoted to the top and bubbles down to its correct spot in the final configuration. So with that in mind, we have, just by using logic alone, the ordering of these operations. Okay, but I know you guys don't really trust me. Let's walk through an example just to make sure. Okay, actually, let's just walk through all of these steps. So we have this starting state, and the first thing that I've claimed we should do is remove min, and that's from the pre-given code. So what we do is we call remove min. Okay, what happens after doing remove min is, okay, pay close attention here. This is like some important heap operations. So after doing remove min, what will happen is A will get destroyed, G will go to the top, and then G and C will swap. Okay, so that's what we want to occur. And I'm going to be choosing these like decisions so that the end state is actually achieved. Okay, because we don't really know if B is greater than C or C is greater than B, but we do know that eventually we need to get to this end state. So I'm going to be making decisions based on that fact that we need to eventually hit that end state. Okay, so after doing remove min, we have this state of the heap. So the next thing that we want to do is insert X. Okay, so we do insert X, and this is actually not going to do too much changing. All that's going to happen is that X is now going to be in this bottom right. The reason here is we want to put X in a position so that when C is removed, right, let's just walk through that. We'd call remove min. Now what happens is since C is in the correct position, when we call remove min, right, X goes to the top, and then X will bubble down. Oh, just kidding. X will bubble down as such. Okay. So Hopefully that makes sense. Then the next thing we need to do is insert A. So we will call insert on A, and we see after executing this operation, what will happen is A will get inserted in this bottom right, and then it'll move to the top because we know A is the smallest thing in this heap, right? And we see here that this configuration is equal to the configuration we expected. So yeah, those are these steps. Exciting. Let's quickly dive into part B, which isn't too difficult once we have these steps, okay? Let's go over these comparisons. The first one is comparing x and d. Do we know if x is greater than d, or do we know if x is less than d? We actually don't. The reason for that is, let's just watch what x does. X is here, which means it got compared to g, right? Then what happens is that x gets promoted to the top, right? X was promoted here. It was compared to B, right? It switched places with B. Then X came here, it was compared to E, and then X came here. So you guys can see that like we never actually compared X to D. So we have no idea about this relationship, okay? So I'm gonna tackle these two in the same pass. If we observe, X is inserted here and it stays in the bottom right corner. This implies that it must be greater than its parents. It must be greater than C and G. Okay, the last thing is that B and C comparison happens after the removal of A. Okay, so after A is removed, we see there is this ambiguity here about whether we should choose B or C to fill A's void, right? Since we wanted C to be removed at a later time, C fills the void, and we know that C must have been less than B. Okay. Perfect. So that is all for this question. It's very tough, but if you guys watched this whole video, hopefully it made sense. Good luck on the upcoming midterm. It'll be a fun one. All right, that's all.